Hello, fam. We are back at it again. All right, today we're doing 191 number of one bits. I'm like deliberately avoiding all the questions that has like data types or like algorithms involved, just test basic programming because I want to get used to the C++ syntax first, um, and then move on to like more complex things, So um, I'm right now taking a DSNA course, so I'm not familiar with those concepts yet. So I want to avoid the lead code questions first. Anyways, that being said, let's get into it. As usual, time limit 1 hour. If I don't do it, then solution it is. Okay. So given a positive integer, write a function that returns the number of set bits. Set bits refer to a bit in the binary representation that has a value of 1, sure. In this binary representation, also known as the hammering weight. Okay. So if it's 11, the input string is 1011. Okay. Input binary string is 11111101. Okay. All right. So my initial thought is yo, 我正确着. Thanks. Okay, so my initial thought is like something module. So let's say 11 mod 2 equals to 1, and that would be equals to odd. So turn the bit on, right? I think. And then 11 mod 4 would be 3. So that's odd. Wait, so the first one should be 11 mod 1 would be equals to 0. So this turn the bit on. Turn on. This one would be off. It's on, so turn the bit off. Question mark would be 3, which would be off. And turn the bit off. 11 mod 8 equals to 3. Odd. Turn the bit off. Okay. Clearly wrong. Let's do 1, 2, 8 mod 1, 2, 4, 8. That was, yeah, 16, 32, 64, 128. Still 0. Right. There's a Hamming weight. Okay. There's how many bits there are on. Okay. Whatever. do this. If it's true, it's like that. It's all five, 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 two, five. This would be one, right? 1, 0. Okay, right. Then this would be turn bit on, right? Turn bit off. Oh, oops. Bit on, turn bit off, and turn bit off. Okay. And if it's 128 divided by 1 equals to 100, then off. Well, 2, 4, 8, 16, 32, 64, and 128. This would be 64, 64, 32, 16, 8, 4, 2, and 1. So this one would be off. So turn it on. Okay, so this should be the way. So in this case, I just need to implement this as an algo. Um, until the last one becomes 1, I would assume. So I would go for I, and I equals to 1, and then I, wow, answer is not full. Uh, false first. And wow, true. And then and then and then uh equals inverse, and then result Okay, so while answer is not 1, the result will be n divided by denominator, which starts at 1. And then if it equals to 1, let's say n equals to 1, right? Right. Let's say n equals to 1, which is the constraint. 1 divided by 1, then the result will be 1. Answer will be true. And answer will be true. Which does not work because count does not increment, right? Wait, what am I doing? Okay, wait. If it's even, then you turn it off. If it's odd, then you turn the bit on. And if it's even, you don't do jack. Right? Right. If it's odd, then you turn the bit on. And then if the result is equals to 1, then answer is 1 will be set true. And then the loop exits and then you return count. And if it's even, then it will not be this, then it will loop back. So here, denominator should do this. Okay, let's say it's 1. 1 divided by 1, it is not, so you go up, and it's 1, so you return, and the return count, so it should be 1. Let's say if it's 2, 2 divided by 1 is, huh? Okay, 2 divided by 1 is 2. So count does not increase. It is not. And then now it's 2. Denominator is 2. So 2 divided by 2 is 1. Then you increase it. And then 1. Count. Okay, let's say if it's 11, right? 11 divided by 1 is 11. So count does not go up. Is 11, so it does go up, right? So that's 1. And it's not 1. Denominator goes up. 11 by 2 is 5. 11 by 2 is 5, so it goes up. 11 by 4 is 2, so it does not go up. 11 by 8 is 1, so it does go up. No returns. Okay, I think it's correct. Find integer overflow. Okay. Long. Go long, go long, A long, A long. Fuck. Okay, does work. Okay. Oh, we got it. Let's see the answer. Yeah, I was thinking about something about the bit manipulation. I don't know if it's man. Input must be a binary string of blank 32. Where is that given? Where is that given? Is it this? Goodbye. Bye, friend. Mongol no. Ocho go now. Bye, bro. Bye bye. Yeah, I want to use the bitwise trick. Um, how do I use the bitwise trick? Um, three, four. Okay, 0, 1, 2, 3, 4, 5, 6, 7. How to turn into bits in the first place? What the fuck? Drops the last bit. N equals to end and n minus one. Wow, that's pretty smart actually. So if I go in count equals to and n minus one, so it drops the latest rightmost bit, right? And then can I, that is so smart. Oh, but it's the same. Very simple. Okay. Well, I did it. See you tomorrow, my friends. Tomorrow, I think I'll get to arrays, maybe. I'm working on pointers now, so if there are any pointers questions, please let me know. Peace.